Rios microcosm. Since I moved to my current neighborhood, I have always enjoyed the man-made ponds throughout it. It adds beauty to the community and it serves as a habitat for many different kinds of birds, including ducks, geese, coots, and herons. There has, however, always been one thing that has made me question the quality of the water. That is the signs posted throughout the community reading, "Recycled water, do not drink." I know that a lot of natural ponds are not doing well with the current global warming issues that we are experiencing as a planet. An increase in carbon dioxide atmospheric pollution is causing global warming. This prompted me to want to run a test of my own to see if the recycled water was healthy enough to withstand our current environmental changes. Could recycled water from anthropogenic ponds replace polluted natural ponds? I wanted to compare the surface water to the bottom. The reason for this is because the surface water is more exposed to atmospheric pollution and does not have the added plant benefits that the bottom does. This is a picture of a sign that is posted in my community. My first hypothesis was bottom samples with more plants will do better than top samples. Adding CO2 will be especially bad for surface water. My second hypothesis was if the recycled water is a safe alternative, it will maintain its clarity and pH balance throughout the duration of the experiment. I used four glass mason jars to collect 2 samples from the bottom of the pond and 2 samples from the surface of the pond. Shreds of paper were added to one of the top samples and one of the bottom samples to supplement carbon dioxide. Week 1, the samples were placed in a box. The box was kept with the lid open and it was used to represent the man-made in-ground lake. I wanted to keep the samples outside to best imitate the natural environment that the samples were taken from. In week 2, some plants and particles still appeared to be floating, but most had settled to the bottom. Week 3, top samples with paper begin to get a bit cloudy. In week 4, weather throughout the week was consistently clear. Samples with paper begin to get cloudier. In week 5, days remain clear, but temperatures begin to warm up to the 90s. And a faint calcium line begins to form at the top of the surface sample with added carbon dioxide. In week 6, the weather changed, so I had to bring the jars inside to examine them. There was a lot of wind and light sprinkles throughout the week. This, however, did not affect the clarity. In week 7, the clarity was consistent and the weather began to warm up once more and the skies began to clear up again. Upon completion of the study, all water samples were tested with water quality test strips. To the right is an image of a table that explains how to read the results of the test. This page shows the water quality data. As you can see, the top samples with added carbon dioxide had very high levels of hardness and alkalinity and high levels of pH balance as well. And from the surface sample that did not have any added carbon dioxide, The hardness, pH balance, and alkalinity were all within normal levels. From the samples taken from the bottom of the lake, the one that had added carbon dioxide had very high levels of hardness and alkalinity and low levels of pH balance. However, the sample that did not have any added carbon dioxide had normal levels of hardness and slightly high levels of pH balance and alkalinity. The first major finding was that plants are the best resolution to battle carbon dioxide pollution. The added plants still seem to be clearing up carbon dioxide that the chemicals in the treated water could not. The second major finding was that the recycled water in my community was properly sanitized. The water without the added paper stayed consistently clear throughout the 7 weeks of the project. These samples with the added paper, remain pretty clear. Samples with paper only got a little cloudy due to the added CO2 throwing off the pH balance of the chemicals, and therefore calcium began to build up in the sample with added water that had no plants. This project has brought me to the conclusion that I am all for recycled water. Future hypothesis to test is, if I perform the same test on natural water, will it react to the overwhelming carbon dioxide the same way that the anthropogenic water did? Further research. Microcosms are an excellent way to look at what is going on in a large body of water by replicating its atmosphere in a smaller sample. Microcosms have helped scientists address issues such as climate change, biodiversity, habitat restoration, assembly rules, and trophic dynamics. All of these topics are very important when promoting healthy communities within an ecosystem.